All right, guys. So this week, we are looking at parts of Chapter 3 and Chapter 4. In this section, we're looking at exponential and logarithmic equations. So we have some function that has an exponent with an x in it. We got to get it out of the exponent somehow. So we're looking at some ways to be able to solve those types of equations. So one way to do this is if there's a one-to-one relationship between common bases, for instance, base b to the power m equals base b to the power n, then you can jump right to the step where you say that the powers must be equal, therefore m has to equal n. Technically, the way that we do that is taking the log of base b for both sides. So log base b of b to the m is equal to m. So let's look at some of those. And then in general, all right, what we're going to do is isolate the term that has the exponent to one side of the equation. Then we're going to try to rewrite the other side of the equation in the same form. If we can't do that, then our next option is to take a logarithm of both sides. And then finally, solve the remaining equation. So let's take a look at this first one. So I have 3 to the 2x minus 5 minus 8 equals 1. I need to get that 3 to a power by itself. So I'm going to add 8 to both sides of the equation. So I have 3 to the 2x minus 5 is equal to now 9. Now that's great because we know 9 can be written as 3 to a power. So what I'd like to do is leave this side unchanged and rewrite 9 as 3 to the second power. Now, as you look above, right, as soon as we get same base, then we can just drop the bases and say that the exponents must be equal. So at this point, we could just go straight to 2x minus 5 is equal to 2. Add 5 to both sides. Right, this is fairly trivial at this point. And then divide by 2. Okay. So again, if we plug that back in, right, to double check, then we have 2 times 7 halves minus 5, the whole thing minus 8, and we're trying to get that equal 1. These 2's would cancel. So you'd have 7 minus 5, or 3 squared, minus 8. That's 9 minus 8, or 1. So it looks like that works out just fine. All right. Let's go ahead and take a look at the next one we have here. So again, we're trying to isolate the thing that is to a power, the term that has a power. So I'm going to go ahead and add 3 to both sides. So I have 1 over 25 to the 2x minus 5 equals 125. So this one, it looks like we might have to adjust more than one thing. We shall see. Right? We all should know that 25 is the same thing as 5 squared. And 5 to the third power is actually 125. So instead of rather trying to get everything to be 25 to a power, I need to rewrite this as powers of 5. So this is really 1 over 5 squared to the 2x minus 5. And over here, this is 5 cubed. Right? There's a rule for exponents that say if I'm in a part of a fraction, then you can put me in the other part of the fraction and my sign of the power will change. So I'm going to rewrite this 1 over 5 squared as 5 to the negative 2. And that's the same thing. All right, I'm trying to get 5 to a power so that I can just get rid of the bases. Then if I have an exponent and then the whole thing's raised to another exponent, I multiply the exponents. So I take this, and this would be 5 to the negative 10x. I'm sorry, negative 4x. I was doing the 2 and 5 already. So negative 4x plus 10. All right, so I'm going to go ahead and multiply this negative 2 with the other powers. So that'll be minus 4x plus 10, and that's equal to 5 cubed. So now that I have 5 to a power equals 5 to a power, I can drop the bases and the powers must be equal. And at this point, it's just a matter of doing some basic arithmetic, or I guess algebra technically, to get to the answer. So I'm going to move that negative 10 over, and that's going to give me negative 7. So it's like x is going to be 7/4. So again, let's think about that. If I plug 7 over 4 in for x, 2 times 7 divided by 4 is going to be 7/2 minus 5. And that's going to be 7 minus 10/2, or minus 3/2. And then it's already 1 over 25. So that's, as we said, 5 to the negative 2, then raised to the negative 3/2. So that's going to be 5 cubed. And that's 125. And then subtract 3, and that gives us 122. So again, it looks like that guy works out just fine. Let's continue here. All right, so this time we've got 16 to a power and 32 to a power. So we could try to do 32 is 2 times 16, but it's better if we get a single base that's the same for both. I happen to know that 2 to the 4th is 16, and 2 to the 5th is 32. So this over here is 2 to the 4th, then raised to the x plus 1. And this is 2 to the 5th, then raised to the 3x minus 4. At this point, I could just multiply the powers for both sides, and they have to be equal because it's all base 2. So this would be 5 times 3x minus 4, right? So I just did 4 times x plus 1, 5 times 3x minus 4. So this would be 4x plus 4 equals 15x minus 20. I'm going to subtract 4x from this side and this side, and I'm going to add 20 to both sides. When I do that, these cancel, and I get 24 is equal to, these cancel, 15 minus 4 is 11. So I get x is 24/11. All right, so let's take a look at D here. Here I see that 27, and we have root 3. So everything looks like it has base 3. So I need to rewrite 27 as 3 cubed, then raised to the x. And instead of square root of 3, that's the same thing as saying 3 to the 1/2 power. And if I'm dividing by that, I can put it in the numerator and then make it a negative power. Okay. So on the left-hand side, we have 3 to the 3x has to equal 3 to the minus 1/2. Again, once we have same base, we can drop the bases. So we get 3x equals minus 1/2. And then just divide both sides by 3. So I get x equals minus 1/6. If you're unsure about that, right? This is minus 1/2 divided by 3, or times 1 over 3. Right? Think of it as 3 over 1 here, and then you can flip and multiply. So it looks like x is -1/6 gets us the same.